So, good morning, people. Let's get started with our new unit, Unit E, which is about planet Earth. Now, we are going to skip chapter 1, 2, and 3 because those chapters are a little bit more technical, and I'm going to need a little bit one on one time to explain those concepts and whatnot. So, we're going to jump straight to chapter 4, and we are going to finish this off during the time that I'm away. And then I'm going to assign you to work on a project that relates to this chapter of Unit E. All right, this is going to be a fun one, I hope. All right, so let's get going. So this chapter is all about fossil records, providing evidence on Earth's changes of how those have come about, how fossils have formed over time, about the different eras of Earth, and things like that. Okay? So I want you guys to know that you have been given a student note pack, and there are going to be certain words and phrases missing from there. So as we are progressing through this lesson, you are going to have to fill those out, okay? I'm letting you know ahead of time that I have not posted this on Teams as yet, so you are responsible to ensure that you do fill out those words and phrases so that you have your own notes to study from. I will post them at an appropriate time before your quiz or test, but as of now, you are in charge of making sure that you are learning and taking those phrases and missing words down, okay? So pay attention. All right. So first of all, we're going to take a look at how tracing evidence using fossils is done. Fossils are essentially traces of once living things that are preserved in rocks. You know what, over here, even though they use the word traces, really not traces. We have had there are big fossils as well that has been found. They form when animals or plants die and sink to the bottom of the sea floor, and then they are buried by layers and layers of sand and sediments. And that means that the sedimentary rock in which they are found, the fossil, are that old, and usually they are millions of years old. In the slides later, there is a picture of a mountain lion that was found dead by a hiker somewhere in Alberta, and sediments have already started forming on it. So within a million years, who knows how technology is going to be? We might be able to exist in holographic mode or whatnot. That lion is going to become a fossil, potentially. All right. So paleontologists, you should know that paleontologists are scientists who study early life form by interpreting animal and plant fossils, okay? Most fossils have to be very carefully removed from the rock that surrounds them. As a paleontologist, actually, you have to be able to determine what is a fossil and what is not. That means that a fossil can look very much like a rock, and you might end up damaging it and breaking it. So the study of paleontology actually teaches you how to do that, how to determine by looking at a fossil and the rock and the minerals around it, and how to extract that fossil out. So fossils, most of the time, unfortunately, are not complete, are not found as a whole piece. They are usually found as part of skeletons, shells, animal traces, and things like that. But once many pieces of a certain fossil are found, they are typically put together, right? Okay. Make sure you're writing those missing phrases and words down. Okay. So not every living thing is going to become a fossil. If that was the case, then, we would have had a lot more fossil fuel than we do. As you have learned, fossil fuel is a non-renewable fuel. That means even though we have an abundance of it, it is going to run out sooner or later. But if every living thing did become fossil, then I think that would be slightly less challenging. That means that they would last us much more longer time. However, the whole process of turning into a fossil is a very rare experience that the dead body experiences, not living beings. Fossils may not just be the actual plant or animal, okay? So a trace fossil is a cavity or track left behind by an organism, for example, a footprint. Or, you guys have worked with or played with kinetic sand. So if you take something and press on it, like press on it and leave like an imprint and you take it out, the imprint that is left, that would essentially be a trace fossil. All right. Casts are the filled in cavities left by the organic bodies. So wherever the living being might have died and might have like sunk in into the soil or the sand and then covered up by sedimentation, and then like, the whole process of fossilization took place, that is called a cast. So these two terminologies are important. So make sure you've made a note of that. Okay. So in fossil formation, essentially sediments quickly have to bury the original plant or animal remains, okay? It has to be quick. If it's not quick, then what happens? I want you to guess what happens. I'm going to give you a few seconds to think about this and then I'm going to start responding. La 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 la. What do you think happens when sediments don't settle as quickly as they should? Well, let me tell you what happens. Okay, they start decomposing, decaying. All right, so a quick burial usually means like scavengers and other decomposers don't get to the body before. All right, so they're unable to break them down, hence they are left pretty much intact, and that's what allows them to get fossilized. Sometimes a cavity is created as the original organic form decays. All right, this cavity can then be filled by other sediments, which eventually harden into a rock. Okay, in many other cases, fossil can be formed when the original organism is slowly being replaced by mineral crystals. All right, so as you know, on Earth and wherever the body has died, there's going to be a lot of different kind of materials around that body, okay, in the air, in the land, in the sea. So gradually what happens is the flesh part and the skin part, those decompose and go away, they decompose, but those are replaced by other minerals and substances and harden up to become like rocks. Trees and other plants can also become fossils, and these marks are sometimes found in the form of petrified wood or remarkably preserved. That is a grammatical error. It's they're found in the form of petrified wood and are remarkably preserved. Okay. Do you guys know what petrified means? Petrified means when something turns into like rock or really hard substance very quickly. That's petrification, and it has happened to trees and plants that have been found fossilized. Okay? All right, moving on. So this is the steps of fossil formation. So make sure you learn the steps. All right, this is a very important question and it can come to you in the point you have to answer in bullet format. So as you can see over here, first this fish died and it drifted to the bottom of the floor. So what you are seeing over here, this is not land, okay? This is like the bottom of the ocean floor. And then gradually it started sinking into the sand deeper and deeper, and layers of sand and sediment started to cover it. Okay, and as more materials start piling on it, the pressure on it increases as well, right? So eventually the sediment with the fish inside, it hardens to a rock. Now when you crack open the rock, you find the impression of the fish's skeleton is preserved, right? And then as a paleontologist, like I said, you would be able to look at it. Maybe not right away, but still paleontologists study this and they would be able to look at it and know where and how to carve and dig out that fossilized fish impression or the fossilized bones of the fish. Okay? All right. So studying fossils is one of the ways that geologists and paleontologists track changes in Earth's geologic history. Okay, just to backtrack a little bit, scientists who study the changes that have been happening to Earth and the behavior of the structures of Earth, which are like the layers of Earth, those people are called geologists, right? And paleontologists are the ones who study like fossils and things like that. But together, these two scientists, category of scientists, they work together to track changes in the Earth's, like, geologic history. So fossilization is a process that can take thousands of years and only appears under certain conditions, okay? Animals with hard parts are the most common fossils. Animals with soft parts such as earthworms and jellyfish have been found, but they, as you can understand, they are rare because they tend to decompose and break down very easily, okay? All right, but they have been found. There are some that has been found, nevertheless. All right. So when you look at a sedimentary rock, and we're going to learn about that, again, we're going to backtrack, but when you look at a sedimentary rock usually has like marks of layers on it, okay? And the layers of sediment that have formed over millions of years are called strata. Okay, very important vocabulary. They provide important information about what happened in the past. All right, and from studying the kind of rock and the grain size, grain is like, if you scratch it off and there's like, the coarse fine, like, the shavings that fall off, those are like the grains. And you study the grain size in a layer of strata, the geologist can gather information about the environment that it had formed in. Okay. Once again, I hope you're filling out those missing gaps in your notes. Okay, so if it's limestone, all right, so scientists can recognize what is a limestone. This layer of rock was originally at the bottom of the ocean, all right? If a layer of strata, if a layer of sedimentary rock is very thick, that means that the environment remained stable for a very long time. Okay, there was not much change in environment. A rise in sea level would show up as a change in sediments along the former shoreline. So beaches around the world, okay, as you know, we have continents, and every single continent is surrounded by water, right? By oceans, and the border of the continents that are surrounded by the oceans, those are called shorelines. All right. Qatar, we are a peninsular country. We are surrounded by oceans. We have shorelines, right? But the shorelines are not constant and consistent. They are changing non-stop. All right. So a rise in the sea level would show up as a change in sediments, like the kind and the type of material that gather up on the shorelines, because water is coming in from all directions and all places and gathering in the ocean, right? Streams, rivers, lakes, and they finally come and join the ocean. And when they're coming from the streams, rivers, lakes, and places, they're bringing with them what is called the sediment load. All right, it's bringing dead substances, it's bringing sand, it's bringing rocks, it's bringing pebble. Those are sediments. So the change in the sediments along the shoreline is what scientists would look at. Okay, so that is a rise in sea level would show up as a change in sediments along the shoreline. The shoreline sediments would be replaced by the type of sediments that form in deep water. Okay, this might be a little bit tricky to understand. Don't worry about it. Just understand that how scientists predict the geologic changes of Earth, looking at various sedimentary rocks and sediments. Okay. So paleontologists use particular fossils to identify certain time periods, and these are known as index fossils. Okay, not every fossil that are found around the earth is used for this purpose. There are certain fossils, and those are called index fossils. Okay, they're used to identify periods of time, and we're going to take a look at those periods of time. You're going to have to learn about those periods of time. Okay, the fossil record found in rocks show a sequence of different life forms appearing through time. For example, single-celled life forms appeared before multi-celled life forms. All right. Plants came before animals. All right. And invertebrates, that is creatures without any backbones, came before vertebrates. Okay, that is creatures that had backbones. This is a There is a typo here. It's invertebrates came before vertebrates. Please make sure you write the correct thing. I will change this when I post the slides on your Teams. I'll make sure to do that. So invertebrates came before vertebrates. That's the statement. Creatures without backbones came before creatures with backbones. All right? Okay. Fossil records show that older rocks contain increasingly different organisms from those living today. Okay. All right. So, the ability to reconstruct fossils based on knowledge of current living things is an important part of understanding the history of life on Earth, right? How would you know to construct something or put together the skeletal form of something that you have never seen before? How did scientists determine that a T-Rex is supposed to look like the T-Rex that we actually see now? Do you think that's true? Do you think like all the dinosaurs that we've seen and learned about, like Brontosaurus, Triceratops, T-Rex, Conotors, like, do you think they actually look like, yeah, if you've seen like, the movie, the Disney movie, like, dinosaurs or other, like, do you really think those animals actually looked like the way that we see them now, or they might have been different? How can we tell? We wouldn't know. We have to believe what the scientists have done, right? So we essentially look at what exists as of now. Okay. For example, like for mammoth. Have we ever seen a mammoth in our life? No, we haven't. But they have come across fossilized bones and structures, number one. Number two, they actually found preserved mammoths, like, bodies as well. And then they figured, okay, this is how you're supposed to put together the skeletal structure, and then you would layer it with the meat and the skin, and then put the fur on it, and potentially this is what a mammoth is supposed to look like, right? So we look at like existing creatures. Scientists look at existing creatures, draw their knowledge and information on that, and transfer it to understanding how fossilized skeletons can be put together to make sense, right? So the obvious challenge for paleontologists to study ancient life is that the animals and plants they're trying to construct and to study doesn't exist anymore, right? Much of what science knows about them is based on inferences and educated guesses, based on what we see today, what we learn today. Okay, so the Burgess Shale fossil beds, is a place actually, and this is a place that have preserved the soft tissue of many species, allowing scientists to study these specimens in detail. This is particularly important to understand in the sense that when we talk about fossilization, most of the time we think that it's only bones and the hard parts and hard structures, okay? But we have cells and tissues and organs. Our organs are squishy parts, okay? So Burgess Shale fossil beds is a place where the squishy soft parts of many species have been retained, okay, have fossilized. And this is thanks to very fine sediments and a very quick burial before the scavengers and decomposers could get to it. So in order, so when that happens, when there is a very quick burial and the burial is done with like very fine sediment, but they're tightly jam-packed, all right, it cuts off the oxygen supply. All right, for that reason, even if there are bacteria in that place that could damage those things, they couldn't do that. All right, so very fine sediments, quick burial, and the lack of life-giving oxygen for bacteria, these shale fossils look much the same as they did about 500,000 years ago. I'm going to try and find some photos and pictures of this and put it in the slides when I upload the slide on there. I don't have them in there right now. All right. So well preserved are the fossils in the shale that the scientists have been able to determine what the final meal of that creature was before they died. Isn't that fascinating? Again, scientists have been able to determine what the final meal they had before they died. I know that place is covered with my face, so I'm telling you, make sure you write that down. Okay, fill in the blanks. Another important place in terms of studying fossils, particularly about dinosaurs and things like that, is the Royal Tyrrell Museum. If those of you who are from Alberta, you know where this place is. So the Royal Tyrrell Museum of Paleontology is located in the Badland areas of Alberta. It opened up on September 25th, 1985. It was named after Joseph Burr Tyrrell, a geologist with the Geological Survey of Canada. In 1884, when he was studying coal deposits in the Badlands, he discovered a 70-million-year-old dinosaur skull and named it Albertosaurus. Okay, you guys should know that obviously, dinosaurs have been found in many places of Earth, but one of the richest and densest places where dinosaurs roamed was Alberta, believe it or not. Okay, so this Badland place is also called Drumheller. Like those are the places where a lot of dinosaur fossils have been found and studied. So this find of this 70-million-year-old dinosaur skull sparked an international interest in the area, which turned out to be one of the richest sources of dinosaur bones, like I just said. All right, and then the Alberta government recognized the area's importance and financed a major museum, and the research facility is in the Badlands. So if you ever go to Alberta, make sure to check this museum out. It's really cool. There's a lot of stuff to see and do in there. Okay, so I just want you guys to know something. This slide about the Royal Tyrrell Museum, this information, I'm not going to test you on this in the main assessments of quizzes and unit test, but bonus questions might be from here. Okay, so if you want to earn those bonuses, study it up. So these are two very interesting photos I came across on Facebook, something that I've given up now. But they randomly came up and I thought, wow, this is so cool. This is something that you guys need to see. So as you can see, this is a very well-preserved dinosaur that was discovered in Alberta, Canada in 2011. Look at how well preserved it is. As you can understand, paleontologists who discovered it had to work very hard to extract it, to make sure that it's intact. But look at that. Isn't that awesome? And remember at the beginning, I was talking about a mountain lion that was found. This is the lion that I was talking about. See? So already a layer of sediment has formed on it. But you can go back and check, a layer of sediment has formed in it. It's a process of getting covered and getting fossilized. Okay. So let's continue our lesson from here tomorrow. And if classes has ended up early, make sure we're going to rewind back and go back a little, but we'll start from here from tomorrow onwards, okay? All right, we're about halfway there, so we have about another maybe 8 or 9 slides to get through, and then you're going to get your handout for a project to build a diorama. Once we get to that, I'll explain the requirements, and the handout is going to be given to you about that. Okay? All right, have a great day.